My name is Jonathan K. Commerfeld. I'm a senior lecturer here at the University of Sydney, and I do research in natural language processing, which is the subfield of AI looking at language. So today I'll be telling you a little bit about language models. So these are systems that take text as input and predict text that follows it. And you probably use one of these almost every day when you're typing on your phone and it predicts the next word you're going to enter. Now, there's been a lot of excitement recently about systems like ChatGPT that are large language models, scaled up versions of what you use, and so I want to explain a little bit of how they work. To start, we take the words that you provide and convert them into vectors. And those vectors are input to a giant mathematical equation. I'm showing you an example here. Of course, it goes on, you can imagine the extra terms. Each of those vectors goes in as x, we crunch the numbers, and the output, f of x, is another set of vectors where each one is a word. Now, that covers x and f of x. What about the letters a, b, c, and so on? Those are the parameters of the equation. That's where the knowledge and understanding of the system lives. We start off by setting those completely randomly. And what that means is that to start, when you provide your input, its output is totally random. That's wrong, of course. So we take the correct output and we say, what would we have to change to make it do the right thing? And we make a small tweak to all those A, B, C, and so on. And now it does a little bit better. Then we do that 1 billion times with data from all over the internet and books and other resources. And the result is a model that makes a pretty plausible prediction. Of course, the actual large language model isn't as simple as a polynomial equation like this one. The actual model is this massive neural network that has learnt billions of these parameters. This training approach has several implications. And I'm just going to mention 3. So one is these models will hallucinate. And what I mean by that is they're giving you a plausible output. They aren't looking up facts in a dictionary or in an encyclopedia. And so that means you'll get a reasonable output, but it might be wrong. Second, they're static. So if the world changes, the model isn't going to know that unless we go and do that training process again. And third, they're going to show the same biases as the data they were trained on, sometimes even exaggerated. And what I mean by that is if you have, say you give it input with a doctor and you ask to produce output, it's going to guess male pronouns if it saw male pronouns associated with doctors in the input text during that training process. And so that bias is being reproduced. Now, all of these are issues that researchers such as myself are working on, and we'll hopefully see a lot of progress on them in the years to come. And these models are going to keep getting better, but I think we're going to be struggling with these, and completely resolving them isn't going to happen overnight.